Welcome to CS 420 Programming Languages. In this lecture we're going to talk about parameter passing. First we'll talk about what expressed values are and what denoted values are. Then we'll talk about call by value versus call by reference. And those are pretty popular in a lot of programming languages. Now not very popular are call by value result and call by name and need. Now call by value or reference, what we're referring to is how we pass variables into functions when we call them. Now in lecture 20, we have some lecture notes about expressed and denoted values. Expressed values are values that are returned from eval expression. These are what you see when you run a function in Racket and it prints out the value after it's run in the read eval print loop in the command area at the bottom. Those are expressed values. Denoted values are kind of internal to the language, and they're the values that we store in the language. Now, so far, our expressed values and our denoted values are exactly the same. What we store in our environment, the values that we store in the environment, are the same values that we return. However, and that's a direct data model. However, we can go to an indirect data model, and in that case, our expressed values are the same, but our denoted values now become a reference to an expressed value. And that's an indirect model. So what's a variable, when we have a variable name, when we look it up in the environment, if it's the same value that we'd return from eval expression, then that's a direct data model. If we have a variable name and we look it up in the environment and it happens to be a reference to our data, then that's called an indirect data model. We're now going to talk about call by reference versus call by value. By the way, when we're talking about call by, that's how we pass parameters into a function. So if we look at this code in extremely easy language, there have been a few expressions added in previous lectures that we haven't covered in these videos. But we declare a new variable a that is equal to 3 and a new variable p that is equal to a closure or a function. Then we call that variable, we call p, passing a in as its parameter. If you notice, the function changes the parameter. It sets its parameter x equal to 4. So this is a variable assignment. And you've done this lots of times in Java. Whenever you say a variable equals something else, that's a variable assignment, and that's what we're doing right here. And then this at the end is just printing out the final value of a to see what happens to a when we do call by value versus call by reference. So you can run this in the interpreters. You can download the interpreters from the files and run this code, and you can run it under a call by value interpreter versus a call by reference. By the way we implemented functions, we did call by value. And there's another interpreter that does call by reference that actually adds quite a bit of code to make call by reference work. But what I'm going to do next is I'm going to show you the environment that gets created when we run this code and show you the difference. So at the beginning of this, we have our initial environment right here, and then the let is going to run, creating two new variables, a and p. A is going to be equal to 3, and p is going to be equal to this closure. Now the closure is going to capture the environment, but not the environment that contains the new variables that are getting created. And it's going to have an ID, that the parameter that it takes in is x, and its body is going to set x equal to 4. So the next step is to call the function. So when we call the function, we're going to evaluate a, which is going to look up a in the environment and get 3 back. And then we're going to pass that in for x. And we need to extend the environment with the new parameter x. So once again, we are extending the environment that the closure captured. And the closure captured this environment, so we're going to extend it with its parameter x. Now what is x equal to? Now this is where call by value and call by reference will be different. So we're going to do call by value first. What call by value says is to make a copy of what is getting passed in. So a is getting passed in to x, and so we're going to make a copy of a. So we look up a in the environment, see that it's 3, and we're going to make a copy of it, and we're going to set x equal to the same thing. So next, let's run the body, setting x equal to 4. So that's pretty simple in what it does. We erase what a is equal to, and we set it equal to 4. Now, our function is done. There's no more code to run here. So we return from our function, and the next thing we're going to print out a, and a is equal to 3. Just like we expect. When we call a function, we don't expect that the function will change our variables. We don't expect that a gets changed. So that's call by value. But sometimes we actually want our functions to change their inputs. We want it to do some work and figure out a new value for a. So the way to do that is to do call by reference. So we're back to the place where we've declared our a, set it equal to 3, and our p is equal to the closure that captured this initial environment. And now we're calling our function and we're passing a in. But this time we're going to pass it in by reference. So we're going to extend the initial environment with our parameter name. And now we're going to pass in the parameter, which is a. So we're passing a into p. And this time we're going to do it by reference. So we look up a in our environment, and instead of making a copy of 3, we will create a reference that points to what 3 is. Now I'm drawing another little box in there to kind of show that, that 3 belongs in this box, and a has a pointer or a reference to that box, and x has a reference to that box. So now let's run our code. So when the body of the function runs, it's going to set x equal to 4. So we're going to look up x, we're going to find it here, and we're going to follow the reference to the box, and we're going to change what a is equal to, or what x is equal to, and we're going to change that to 4. And now that's the rest of our function, so we're going to return from our function, and now when we print out a, the value of a is different. So call by value, so this code right here, if we're doing call by value, a is left unchanged and the final result is 3. If we're doing call by reference though, that allows the function to change its inputs or its parameters, and a will become 4. Now, call by reference only makes sense when we're passing a variable into the function. In this case, we're actually doing some math. So it's some other expression that we're passing into x. So if we're passing a variable into x, that means that we can do call by reference. But if we're passing in actual code in for x, call by reference doesn't make sense. So we revert back to a call by value, where we make a copy of the result of evaluating this. Now just to show you an example of why call by reference might be useful, have you ever wanted to swap two variables and have a be equal to 4 and b be equal to 3? Well, here's a function that swaps two variables. But if we can't change the variables that we're passing in, how can this function swap them? So by doing call by reference, we'll actually accomplish changing a and setting it equal to 4, and changing b and setting it equal to 3. Now call by reference does come with a downside, and that's called aliasing. We're basically creating more names for the same value. So in this program right here, we have one name for a, another name for b, so that's two different values with two different names. But when we call this function, if you notice, I'm passing b in for x and b in for y, and now b has three names. It has the name b, it has the name x, and it has the name y. Now this function might not know that x and y are the same value with two different names, so by changing x, it's also changing y. And that can lead to some bugs, assuming that x and y, because whoever wrote this function is going to assume x and y were two different values. But suddenly, when they're the same value, that can introduce some bugs. And you can look down here at this swap function that uses some math to swap values. And normally it works until you end up swapping the same two values. And suddenly it turns both variables into 0 and doesn't accomplish its task. So just so we can see this aliasing, I've gone ahead and drawn up the environment that gets created with this. So we have our initial environment. We're going to extend it with A, B, and P. A is going to be equal to 2, B is going to be equal to 3, and P is going to be a closure that captures this initial environment. Then when we call P down here, we're going to extend the environment that the closure captures, passing in x, well, extend it with the names x and y because those are the formal parameters. And now we're going to pass in b as both of the parameters. So what that means is x becomes a reference to that, and y becomes a reference to the same box. So now in our code, when we go ahead and set x equal to 4, we look up x, follow the pointer, and we change its value to 4. But now when we return y, we look up y in our environment, we follow it to the same box and see that y is now equal to 4. So that's okay, but if the person who created this program didn't expect x and y to be the same value, point to the same box, that could introduce errors. Now, because of aliasing by callbyreference, they've come up with a new callby that's called Callbyvalue result. Now, this isn't necessarily new, it's been around for a while. However, it's a pretty expensive operation and it doesn't perform really well, so it's not very popular and is not in a lot of programming languages. But just so we can see what callbyvalue result does, is the goal is to achieve callbyreference but eliminate the aliases. So we're going to go over this example right here and see how callbyvalue result avoids aliasing. So in this function, first we're going to declare a and set it equal to 3. And then if you notice, we have the body, and the body is another let that's going to declare p, and p is going to be equal to our function. Because there's two lets, that allows p to capture a in its environment. So finally, we're going to call p and pass in a, and this is the body of p right here. So if we're going to do callbyreference, then x is going to be a reference to a right there. And now the first line of code is we're going to increment x and change its value. So by looking up x in our environment, we'll follow it down here. We'll see that x is equal to 3. We'll add 1 and change the value to make x equal to 4. Then on the next line of code right here, we're going to add a and x together. Now it can look up a in the environment because it was able to capture it. So we look up x and we see 4. We'll look up a, we'll see 4. We'll add the two together, and the final result will be 8. That's if we're doing callbyreference. So what we didn't expect, though, was that x and a are the same value. So now let's see what happens when we do callbyvalue result. So what callbyvalue result is a copy in and copy out. So it's kind of like we're going to do callbyvalue to start. So when we pass a into our function for x, we're going to find this 3 and we're going to make a copy of it. So x gets its own copy of the value. But at the same time, we want to do callbyreference, so we're going to remember where this variable came from. Now we're going to add 1 to x, so we'll increment x, and now we're going to add x and a together. So when we add x and a together, 4 plus 3 is going to be 7. Then when the function finishes, we still want to be able to change the value of a. So what we do is we follow this reference and we do a copy back. So what that means is we're going to take this 4 that is up here and we're going to copy it back and replace the 3 with 4, and that's after the function runs. But the result of running the function is now 7 instead of 8, as if we're doing call by reference. Now let's talk about call by name. And this is another way that we can pass in variables. Call by name only applies when the variable that we're passing in is some code to run. Before, with call by value, call by reference, and call by value result, we're always passing in another variable to the function. In call by name, we're passing in some code to run. In this case, we're adding A and B together. So normally what we would do is we'd add this together first and then pass it into the function. But call by name does lazy evaluation. What that means is, what if I don't even need to use this parameter? What if I never use it in my body? I'm not going to evaluate that until I need it. So as soon as it needs the value right here, because it has to return it, then it will evaluate this expression and figure out the right result. So this could be a little more efficient if we don't evaluate things unless we need them. Then it will be a little more efficient. Now remember, this is a simple example. There might be if statements in here that decide whether we do one thing or another thing. So there could be cases where we don't use the parameter and we'd actually save ourselves time. So I call this the college student's way of working because they never start their homework until it's absolutely due. So that once they see that the homework's due, then they'll start working on it. So that's the call by name does lazy evaluation, and he doesn't evaluate its parameters until it absolutely needs them. So in this example, we create two variables A and B first. Then we're in the body, we're going to declare a new function, a P, that's going to be a closure, and that closure is going to capture A and B. Now if you notice, the function takes in one parameter called x. And then when we call the function down here, we're going to extend the environment that the closure captured with its parameter name, and we'll do this first the call by value way, or the normal order way. So what we'll do first is we'll look up A in our environment and see that it's 3, look up B in our environment, see that it's 4, add those two results together and set them equal to 7. Then inside of our function, we'll go ahead and change A and set it equal to 4. And we'll return x, and we'll see that x is equal to 7. So that's call by value. So what if we do call by name instead? So what call by name does is instead of evaluating its parameter, it saves it to run it later. And it saves it in something that's a lot like a closure. The only thing is there's no parameters. A closure has code, the body, and an environment to run it in. And that thing is called a thunk. A thunk is a closure that doesn't have any parameters. So what x really gets bound to, instead of x getting bound to 7, it gets bound to the code that we would run if we were to pass it in, but we haven't run the code yet. And that is called a thunk. Now, what we'll do next is we'll set A equal to 4. So we'll look up in our environment and we'll find A and we'll change it to be equal to 4. Now the next line of code that we do in our function is we look up x. So we're going to look up x and find that it's bound to something that we haven't evaluated yet. So we're being lazy, we haven't evaluated that yet. So now we're like, oh no, I need that value. So we'll go ahead and run this value And if you notice, it saved the environment as well, so we can find what A and B are equal to. This time when we add A and B together, we're going to get 8 back. So then our function will end up returning 8. So normal call by value returns 7 because we do the addition first before we change A, and we return 7, versus call by name, which does lazy evaluation. It changes what A is equal to first, and then it does the addition later. Now, lazy evaluation happens to be pretty good. When we don't use our values, we save ourselves time. So we don't end up doing work that we don't use. However, in this case right here, you can see that we're looking up X 3 times in our environment, which means if we just do call by name, we end up doing this addition 3 times, once for each time we look up the thing in the environment. And that's what call by name does. Call by need, however, after we look it up the first time, we decide, you know what, I don't want to do that evaluation again. I'm just going to remember that X is equal to a certain value. So if we go back to this example, when we look up X and we run this code, we keep X bound to this thunk. So if we're going to look up X another time later on, we would have to rerun the code. And that's call by name. What call by need will do is once we run the code one time and figure out that X is equal to 8, then we'll replace this with the actual value. So if we look it up again, we won't have to rerun the code. And that's the difference between call by name and call by need.